Welcome back. In the last lecture we left at the point where I've given exercise to find FOG and GOF of two functions which I have given that problem, and the problem was find FOG and GOF of, suppose this is fx 2x plus 3 and gx is equal to 1 by 2 x minus 3. What I have asked was to calculate GOF and FOG. So the agenda for today is inverse functions, one-to-one function, existence of inverse function, horizontal line test for inverse function, finding the inverse of a function. We will start our study with these example which we have left last time. Right. Now we want to find GOF. GOF is equal to G of fx is equal to, we just put fx in place of x in gx, that is, it will become half 2x plus 3 minus 3 is equal to 1 by 2 2x plus 3 minus 3 is equal to 3 cancels, is equal to x. Similarly, if we calculate f of g is equal to f of gx, that is, in place of x in fx we just put gx, that becomes twice into 1 by 2 x minus 3 plus 3 is equal to 2 cancels out, x minus 3 plus 3 cancels out, is equal to x. So here we have a peculiar situation in which these two functions, for these two functions defined above, f of g is equal to g of f, g of f is equal to x, right? This is the basic definition of inverse also. What is the definition of inverse function? I am giving a formal definition of inverse function. Let f and g be two functions, this is function, such that f of g is equal to x for every x in domain of g and g of f is also is equal to x for every x in domain of f. Then g is inverse of f, and also F is inverse of G. This is the formal definition. This should hold. We take another example to make our understanding better. Let fx is equal to 2x plus 3 and gx is equal to half x minus 3. If we calculate f of g, you can calculate yourself, it will come as x. And also g of f, if calculated, it will come as x. So both conditions are getting fulfilled. That is, fx and gx are inverse of each other. What is the meaning? Why these are inverse? If you see fx, what we have done, we have multiplied by 2 and addition by 3. Right? Multiplied. In gx, what we have done? Subtraction by 3 and division by 2. So what is inverse function is doing? It is replacing addition by subtraction and multiplication by division and vice versa. Right? So this is basic meaning of inverse. Now let us plot this function. So let us get some points of this function. Suppose this is s, x, this is fx. This is 1, 2, 3, 4. 1, 2, 3, 4. Now you can calculate the value. That will come 1, 5, 7, 9, 11. Now we calculate x and gx. If we calculate these values, x is equal to 5, x is equal to 7, 5, x is equal to 9, x is equal to 1, you will find that the value of gx comes as 1, 2, 3, 4. That is, this value is matching with this value and 2 is matching with this value, 3 is matching with this value. So what is the outcome? That is the ordered pair. Ordered pair has reversed. What is meaning of ordered pair that reversed? That is, in the fx, the ordered pair was 1, 5, 2, 7, 3, 9, 4, 11. This was the relation. This was the function ordered pair and relation in fx. However, in gx, what is the ordered relation? 5, 1, 7, 2, 9, 3, 11, 4. So you see, the places have changed. This is gx, which is inverse of x, inverse of fx. So in inverse of fx, the places of ordered pair just changed. Right? So if suppose in some problem an ordered pair is given and the question asks what is the inverse of that ordered pair, you just reverse the x and y, you will get the ordered pair. But there is a big but. For ordered pair, It is not necessary that inverse ordered pair is a function. What does it mean? Suppose you reverse the order and you try to find that exactly one element in the domain, in every element in the domain is matched to exactly one element in the range. It may not be possible. It may not be there, and it may not be the case in every problem. So you have to check this. What I am talking about ordered pair. I am not talking about ordered pair of functions. I am just talking of ordered pair. Ordered pair of function is separate, not ordered pair of functions. Pair of functions. For ordered pair of functions, then there should be one-to-one correspondence, which will be our next topic. We should do. Okay. Now we discuss now we discuss what is the next topic. Existence of inverse. Existence T and C. And inverse function. That is when inverse function exists or not. Suppose a function is given, we want to find out its inverse function. So we have to first verify whether inverse exists or not. Then only we will be calculating the inverse of that function. A function need not to have an inverse function. For instance, fx is equal to x square has no inverse. To have an inverse, there should be a property called one-to-one. That is, function must be one-to-one. Existence implies function must be one-to-one. One-to-one. I will explain the meaning of this one-to-one from the definition of function for ordered pairs. Function for ordered pairs. We studied the ordered pair is a function if each element in the domain is matched exactly with one element in the range. So this we have already studied. Suppose 1, 2, 3 are in the domain and ABCD in the range. So if this is the case, then this is a valid function. However, this is not one-to-one. Why? What it says, for one-to-one function, two different inputs in domain corresponds to two different outputs. Outputs in range. What does it mean? Suppose we draw a range 1, 2, 3 A, B, C, D. This is a valid one-to-one correspondence. That is, every element in domain should be matched to separate element in the range. and no element in domain should be left out. The element in the range can be left out. So the above function in the above 1 comma 2 were assigned to A. This is not a one to one correspondence. What should happen? 1 should correspond to A, and 2 corresponds to B, and 3 corresponds to C. Then this is one to one correspondence. So for a function to have an inverse, the function should be having one to one correspondence, then only inverse exists. Mathematically, what does this mean? Mathematically, this was the I showed through ordered pair. Mathematically, it means if FA is equal to FB, then A is equal to B. What is the significance? What is the meaning of this? Then one to one. And we take the same example which we have considered earlier. Suppose fx is equal to 2x plus 3. Right? Suppose fx is equal to 2x plus 3. So fa is equal to 2a plus 3. Fb is equal to 2b plus 3. We take left hand side of this first equation. Fa is equal to Fb. It means 2a plus 3 is equal to 2b plus 3. This implies a is equal to b. So 2x plus 3 is a one to one function. Similarly, other functions can be checked for one to one. Now suppose fx is equal to x square. Fx is equal to x square. Right? Now we put fa is equal to fb. This means a square is equal to b square. This implies a is equal to plus minus b. Right? So a is equal to plus b also, a is equal to minus b also. So our definition requires only a plus a is equal to b, but here it is coming minus b also. So x square is not a one to one function. What is I explained it through ordered pair. I explained it mathematically. What is the significance graphically? For a function to be a one to one correspondence, it should pass horizontal line test. What is that horizontal line test? That is, we draw a line parallel to x-axis at different points on the graph. If that horizontal line that is parallel to x-axis line cuts the graph at most one point, then the function is one to one. Suppose these are the coordinate axes, and this is our graph. We draw a horizontal line. Right? This is our horizontal line parallel to x-axis. Now you can very well see this horizontal line cuts the graph at 2 points. So this is not a one to one function. One to one function. What was one to one function? Two different input in the domain correspond to output range. Here, if x is equal to, suppose this is x1 this is x2. So these 2 points, suppose this is y1. So the coordinates of x1 comma y1 and x2 comma y2 y1 exist on the both exist on the graph. But our definition is same point, one element in the domain should match only one element in the range. However, here x2 is also matching y1 and x1 is also matching y1. So it failed. Horizontal line test. So its inverse is not there. Not there. That is, we are getting two values. As we have seen, we are getting a plus b. A is equal to plus b also. A is equal to minus b also. Another property of the function and inverse function is, as we have seen earlier also, suppose 1 5 is the ordered pair for function, then 5 1 is the ordered pair for inverse. That is, suppose AB is AB lies on graph of f, then BA lies on graph of f inverse. This is the notation for inverse. We just put a -1 sign. This is not a power. This is not a power f power -1. This is the notation for inverse notation. F inverse, likewise G inverse, or something like that. And what is the property? Graphically, what is meant by the inverse? Suppose this is our coordinate axis, and this is line. Sorry. And we draw a line. X is equal to y at this coordinate axis. X is equal to y. That is at 45 degrees. This is y-axis and this is x-axis. If we draw then a line at 45 degrees, then the graph of a function and its inverse will be mirror images with respect to this line. Suppose we take a mirror here, then and our graph is this, then its inverse function will be mirror image like this. This is mirror image of this with respect to mirror at x is equal to y. This is a graphically we can, if such thing happens or such thing is found, then both graphs are inverse of each other. Right. Now two important properties of horizontal line test. If function is continuously increasing in some domain or continuously decreasing in some domain, then increasing, decreasing, then f is one-to-one function. What is meant by increasing? For x1 greater than x2, fx1 is greater than fx2 for all This is the notation for all x. Then increasing function. However, if x1 greater than x2 and fx2 is less than fx2, fx1, x2 for all x, then decreasing function. This is decreasing function and this is increasing function. Suppose function is increasing in the domain defined for the function, then function is 1 to 1. And if the function is decreasing in the domain defined for that function, then function is also 1 to 1 within that domain. Right. Now only one topic is left for inverse, that is finding inverse. Finding inverse of f function. Algebraic. There are certain steps. First step is check whether f is 1 to 1 or not. How to check? We draw a graph. If we draw a graph, then horizontal line test. This set means horizontal line test. If we take the algebra, I have already explained, then fa is equal to fb implies a is equal to b. This is mean implies. We have to perform these two tests on the function. If these two holds, then we can proceed for finding the inverse of a function. I will explain inverse of a function through an example, then I will give a formal definition of an inverse of a function. Suppose you want to find an inverse of a function fx is equal to 5 minus 3x divided by 2. So you have to first check whether it is a 1 to 1 correspondence or not. I will not check it, I have already shown previously. Assuming this is 1 to 1. The step 2 is, step 1 I have done, that is checking of 1 to 1. Step 2 is equal to put fx is equal to y. That is, now function becomes y is equal to 5 minus 3x divided by 2. Step 3, replace x by y and y by x. That is, this equation now transform to x is equal to 5 minus 3y upon 2. That is, in place of y I have put x, in place of x here I have put y. Right. Then I solve for y. Step 4, solve for y. Our equation is this one. So 2x is equal to 5 minus 3y. So 3y is equal to 5 minus 2x and y is equal to 5 minus 2x divided by 3. This is equal to f inverse of x. Now you can check, our original function was 5 minus 3x upon 2. Here 2 comes, here 2 was in division, now 2 is coming in the multiplication. 3 was in the multiplication of x, now 3 is coming in the division of x. So something look like now answer is correct. Now how to check whether we have got the exact figure is just you check FOG and GOF. Both values should come as x. Then check. Then inverse is verified. right? One thing also is there that if we take function of inverse of a function, where it is uh, I will explain it in an example. This completes, I think, one more thing. Inverse is not always easy to find. Here we have clearly identified y, but always finding an inverse of a algebraic expression is not easy. It may give us some powers of y or some difficult equation where you cannot write mm, y on the left side and x on the right side. So inverse finding is difficult also. One more thing, yes, now I recall. Suppose f and g are inverse functions, then domain of f is range of g, and range of g becomes range of f becomes domain of g. That is, range and domain interchanges their role in the inverse. For example, suppose a function is fx, its domain is defined interval 2 comma 3, and range is all infinity. This is fx, this is domain, this is range. Suppose this is the case, then what is the range of g? Range of g, which is inverse of f, range becomes uh, 2 comma 3, and domain becomes minus infinity comma infinity. That is the role of range. Here it was range, now it becomes domain. Here it was domain, now it becomes range. If you recall, in some earlier lecture I have told that it is very difficult to find out the range or understanding the range of a function. Domain is clearly visible, that we have to identify where the point is, where the function is undefined, or the radicals, especially even radicals. Then we can easily find out the range. Oh, sorry, the domain. However, for finding the range, it is very difficult. I am told at that point. Now, how to find a range of function? Range of a function just calculate its inverse and find domain of inverse. This will be equal to range of f. This is how I used to calculate when I was a student, range of a function. But first please check one-to-one correspondence. One-to-one correspondence. With this I have finished the requirement or prerequisites for trigonometry. I have skipped one chapter, namely the graph of a function, and in which even odd functions, rotation of function is defined, which may not be necessary for understanding trigonometry at the level of high school. So I am skipping that chapter. However, whenever I take the full pre-calculus lectures at that point of time, or whenever it is required in the trigonometry, I will be explaining or taking that details for further understanding. In the next chapter, next lecture, we will be taking some problems on this inverse of a function, and we will close this prerequisite and we will start trigonometry. Hopefully from Monday or Tuesday, whenever I get time in the evening, I'll be making some lectures on the problems, then trigonometry. Have a nice day. Enjoy your time. Thank you.